Everyone, welcome to our channel. So today we are going to discuss two more questions in this video. Both the questions are associated with the steady state temperature distribution, and because we know that the steady state temperature distribution can be represented by Laplace's equation, so basically we are going to solve the Laplace's equation through these two questions. Okay. So let us start. Let us first start with the question. What does the question say? The question says that a thin rectangular metal plate of length L and width V is sandwiched between two sheets of insulation. So like this, it is sandwiched between two sheets of insulation. That means at the top one insulator, at the bottom one insulator. So from the figure, it is clear that there is no flow of heat along Z. But it all depends upon the thickness of the sheet. If the thickness of the sheet is very thin, then we can say that no flow of heat along that direction. If the thickness of the sheet is high, then in that case, that means there is a flow of heat along the z direction also. So let us check. Let us read ahead, okay, and check what the conditions are. First of all, we got that length is L. Let us take the length along x-axis and width along y-axis. So width is b. So y-axis, the value of y varies between 0 to b, and length is L. Length is L means the value of x varies between 0 to L. The next, the temperature of the plate is held at a T0 at the top. Now, because there is no flow of heat along Z, let us assume that the plate is very thin. So because there is no flow of heat along Z, so we can take is equal to y is equal to b is the top side of the plate, and x is equal to L is the right side of the plate, and x is equal to 0 is the left side of the plate, and y is equal to 0 is the bottom of the plate. So when y is equal to b, the temperature is T0. And when y is equal to 0, the temperature is T1. Okay. So when x is equal to when y is equal to 0, the temperature is T1. When y is equal to b, the temperature is T0. This is the second boundary condition. Then at its bottom edge and 0 degree Celsius on the left edge. Left edge means when x is equal to 0, this side. When x is equal to 0, okay, this one. Then t is equal to 0. X is equal to 0, then t is equal to 0. The plate is insulated on its right side. As the plate is insulated on the right side, there is no heat flow through the right side. So we can say the partial differentiation of T when x is equal to L with respect to x is 0. So this one is the condition. The partial differentiation of T when x is equal to L with respect to x is 0. Okay. So these are the two boundary conditions that are given to us. Let us read further. Since the plate is very thin, we can assume that the temperature does not vary in z direction. Already we discussed about that. The plate is very thin. So for our question, it is necessary that we should assume the plate is very thin. Even if it is not given, we have to assume that very thin. If not, then we will get one more term here. Okay, one more term here. Del square t xy by del z square. Okay. So whatever in this case it is given that plate is very thin because the plate is very thin. So there is no flow of heat along z direction, no variation of T. Therefore, the steady state temperature distribution of the plate obeys the two-dimensional Laplace's equation. So it will obey the two-dimensional Laplace's equation, which is del square T by del x square plus del square T by del y square is equal to 0 for x varying between 0 to L and y varying between 0 to B. This is our first equation that we have to start with. Okay, clear? So let us write the first equation, okay, here. So the Laplace's equation for the steady state temperature steady state temperature distribution of the plate of the plate is given by what it is, del square T by del x square plus del square T by del y square, okay, is equal to 0, where T is a function of the x and y. Okay, so instead of writing T x comma y again and again, I just wrote T x comma y as T. Okay, good about it. Let us take this one. Another thing is that x and y being variables, so we need to know the uh, what you can say, limits of x and y. So we can say 0 to L, x varies between 0 to L, y varies between 0 to B, and this is equation number 1. The next figure B shows that the two-dimensional view of the plate in the x-y plane. Since the plate is insulated on its right edge, no heat flows in that direction, and the partial derivative T in that x direction is 0. Already we have taken this one in this, we discussed this one in this boundary condition, so no need to discuss again. Okay, right again. Next, solve the given Laplace's equation for these boundary conditions. Now we have to solve this Laplace's equation for these two boundary conditions. Okay. So to begin with, we should start with to begin with, we should recall the method of separation of variables. Okay. And in that process, in the first step, we have to reduce the given partial differential equation into ordinary differential equations. Okay. Clear about that? And that also involves many substeps, and in the first substep we have to represent the t as a product of two functions of independent variables x and y. Okay, how can you do that? So by using the method of separation of variables, we can write what we can write. We can write like this: T x comma y is equal to x x y y. This is equation number 2. Okay, so x is a function of x, y is a function of y. We have written like this. Now differentiating this with respect to x and y separately, what we will get? So differentiate T x comma y partially with respect to x and y to get. What we will get? Del t by del x is equal to dx by dx into y. So while differentiating a function partially with respect to a variable, the functions of other variable are treated as constant. So y is constant here. Okay, and del square t by del x square is equal to d2 x by dx square into y. Again, del t by del y is equal to dy by dy into x, and del square t by del y square is equal to d square y by dy square into x. Let us take this as equation 3. Okay. Now substitute these values into equation 2. Okay. Equation 1. Okay. Equation 3, this del square t by del x square, del square t by del y square into equation 1. Okay. So what you will get? substituting the values of del square t by del x square and del square t by del y square into equation 1, we get, what do we get here? So d square x by dx square into y plus d square y by dy square into x is equal to 0. Okay, now we have to eliminate this y from this term, first term, and x from the second term. In order to do that, let us divide the whole equation by xy. Okay, so divide the whole equation, the equation by x, y to eliminate, okay, the functions of other variables, other variables from a term, from a term. Okay, so what we will do here, when this term will be divided by xy, yy will be cancelled, we will get 1. Okay, this will give us, this will give us, what it will give us, 1 by x d square x by dx square plus 1 by y d square y by dy square equal to 0. Okay, so this will give us like this. Let us, okay, check the equation. So the equation has two terms. One term is associated with x, which is a function of x, whereas the second term is associated with y, which is a function of y. So now separate them, okay, by rearranging the terms on the left and the right hand side. That means the whole of the term, okay, containing y as a function of y should be moved to right hand side. Okay, let us move it to the right side and solve it. Okay, so what we will get here, 1 by x d square x by dx square plus sorry, this one, we will move the other term to the right side. Okay, so what we will get, this is equal to minus of 1 by y d square y by dy square is equal to minus lambda square. Okay, say, let us take this one is minus lambda square. Now what is minus lambda square? Where minus lambda square is equal to separation constant. Now you can question, why should we take a minus sign before it? Okay, so let me tell you that that means in the condition, okay, in that condition it is clearly mentioned that when x is equal to 0, t is equal to 0. When x is equal to 0, t is equal to 0. That means what? Because y cannot be 0, because y cannot be 0, so that means what, x0 is equal to 0, x0 is equal to 0. So x cannot be a hyperbolic function. Okay, that will make our work difficult, even more difficult to find the answer. So the boundary condition is requires that x0 is equal to 0. So taking the hyperbolic solution would be difficult for us to solve or come to a conclusion. So in order to avoid such kind of difficulties in coming to a solution, we just added a minus sign before it, so that that hyperbolic function can be eliminated from the solution of x. In case of y, if it comes, then also no issue. Why? Because we will keep it as it is. Okay, so what it will give, it will give us two equations like this: 1 by x d square x by dx square is equal to minus lambda square, and minus 1 by y d square y by dy square is equal to minus lambda square. That implies this x, when will come to right side, what it will give, d square x by dx square is equal to minus lambda square x, and minus minus cancel, d square y by dy square is equal to lambda square y. This will give us two ordinary differential equations. So according to the separation of variable method, we just reduced the given partial differential equations into two ODEs as follows. What they are? That is d square x by dx square plus lambda square x is equal to 0 and d square y by dy square minus lambda square y is equal to 0. These are the two required ODEs. Okay, so this is equation number. Okay, what is the equation number? 4, 4, 5. This is 4, equation number 4, and this is equation number 5. These two are the ODEs. Okay, clear? So these two are second order differential, ordinary differential equations. Okay, so thus we reduced the given partial differential equation, that is Laplace's equation, into two ODEs, two ordinary differential equations of second order. Okay, clear for that. Now the assumed solutions. Now the assumed solutions of these two ODEs are what they are? X of x is equal to a cos lambda x plus b sin lambda x, equation number 6, and y is equal to c cos h lambda y plus d sin h lambda y 7. Okay, now we got x and y here. Let us now apply the first boundary condition. Okay, applying the first boundary condition. So what is the first boundary condition? Say the first boundary condition. Okay, means first condition of the first boundary condition. First condition. Okay. So what it is? So when x is equal to 0, t is 0. That is the first one. That means t of 0, y is equal to 0. Okay, that implies what? T of 0, y means x 0 and y is equal to 0 using equation number 2. In equation number 2, what we have? Equation number 2. Okay, let us recall equation number 2. What is there in equation number 2? In equation number 2, we are given that t of x comma y is equal to x of x, y of y. That implies what? Because y cannot be 0. Okay, so x of 0 is equal to 0. Since y can't be 0. Okay, so x of 0 is equal to 0. That implies what? X of 0 means now x of x means a cos lambda x, b sin lambda x. Now x of 0 means a cos 0 plus b sin 0. That implies a cos 0 plus b sin 0 is equal to 0. That implies a is equal to 0. Why? Because cos 0 is equal to 1 and sin 0 is equal to 0. Okay, so in this way we got a is equal to 0. Now substitute this value a is equal to 0 in x. Okay, what you will get? X of x is equal to b sine lambda x. Okay, so substituting this value of a into equation 6, we get, what do you get? That b is equal to x is equal to xx is equal to b sine lambda x. Okay, this is equation number, what is the equation number here? 8. Okay, equation number 8. Next, we got xx. Let us now apply the second condition of the first boundary condition. Okay, now apply the second condition of the first boundary condition. Okay, now what is that? It is given that del t lx with respect to del x is equal to 0. There is no flow of it on the right side. Okay, what does that mean? This means del t, and this is y, y, del t l or xy. Let us take x comma y with respect to x at x is equal to L is equal to 0. That implies what? Partial derivative of x. Okay. Now txy is what? Txy. We know that xx is equal to b sine lambda x. And yx from equation number 7. C cos h lambda y plus d sin h lambda y. Let us write as it is. So that is C cos h lambda y plus d sin h lambda y into b sin lambda x. Okay, into b sin lambda x. This one at x is equal to L is equal to 0. Now, when we differentiate a function with respect to x, okay, the functions of other variable are considered as constants. That means this is a constant, this is also a constant. Okay, this is also a constant, this is also a constant. Okay, so let us take this constant out, b and all these things out. Only this will be differentiated. Okay, so what you will get? That implies c then cos h lambda y plus d sin h lambda y whole into b lambda cos of lambda x at x is equal to L equal to 0. Okay, got this one. Then next, replace x by L. What you will get? Now c cos h lambda y plus d sin h lambda y into b lambda. Okay, this one cos lambda L equal to 0. So see, this term cannot be 0. This is y. This b and lambda also cannot be 0. So finally what? To get a uh, that means what? Finite solution, cos lambda must be 0. Okay. This cannot be 0. This and this also cannot be 0. So cos lambda L should be 0. That implies cos lambda L must be 0. That implies when cos lambda L is equal to 0, so lambda L is equal to lambda L is equal to what you can write? 2n minus 1 into pi by 2 into pi by 2 for n is equal to 1, 2, 3, 4 dot dot dot. We can take n is equal to 0, 1, 2, 3, 4 if we will take here plus 1. Okay, so 2n plus 1 means 0, 1, 2, 3. 2n minus 1 means 1, 2, 3, 4. Okay, whatever you will take, it doesn't matter. Answer will be always same. That implies lambda is equal to what? 2n minus 1. Then this L will be brought to the right hand side. We will get pi by 2L for n is equal to 1, 2, 3, 4. Now look at the right hand side. In the right hand side, we are not getting one lambda. We are getting many lambdas for different values of n. So that means that we can represent lambda as lambda n because we have n number of solutions. So lambda n is equal to what we are getting? Now 2n minus 1 by 2l whole into pi for n is equal to 1, 2, 3 dot dot dot. Okay, so in this way we got what is the value of lambda n here. Clear? What about it? Next, let us go for calculating Tn xy. Okay, so the general forms of x and y, the general forms of x and y are. How can you write that one? Now xn, that can be written as bn sine lambda n x, and yn can be written as cn cos h lambda n y plus dn sin h lambda n y. Clear? Xn and yn will get like this. Now the general solution is Tn x comma y can be written as this into this. So write them. Okay. So Cn cos h xn y, this one is lambda n, sorry, cos h lambda n y plus dn sin h lambda n y into bn sin lambda n x. Okay, bn sin lambda n x, or we can write bn cn cos h lambda n y plus bn dn sin h lambda n y into sin of lambda n x. Clear? Now what you will get? Okay, that is equal to, let us take b and cn as pn. So pn cos h lambda n y plus b and dn as rn sin h lambda n y. Okay, so this into sin of lambda n x, where we can write where pn is equal to bn cn and rn is equal to bn dn. Now we got Tnxy is equal to this much. Okay, clear about that? Let us take this whole term as a gn. Okay, as a gn. So what we will write here? Now Tnxy can also be written as gn sin lambda n x, where gn is equal to pn cos h lambda n y plus rn sin h lambda n y. Okay, let us keep this one as a equation. So Tn x comma y is equal to this much. This equation will be This one is equation 8. So this one is equation 9 lambda, value of lambda, and this is equation 10. Equation 10, where actually t and xy we got g and this ones. Okay, let us now apply the second boundary condition. In the second boundary condition, it is given that when y is equal to 0, okay, when y is equal to 0, okay, for any value of x, what it is given? When y is equal to 0, any value of x, it is t1, okay, it is t1. See here, it is t1 for any value of x. Similarly, for y is equal to b, y is equal to b, for any value of x, it is t0. So let us apply these two conditions now. Okay, what we will obtain? Okay, now applying second boundary conditions. Boundary conditions. Okay, secondary boundary conditions. Second boundary conditions. So let us write them like this. One is t of x and y is equal to 0 will give us t1, and here t of x, and when it is b it will give us t0. Okay, these two we will solve in this way. Okay, clear? Okay, so tx0 is equal to t1. What is txy? Txy we have already obtained. What is txy? This one is txy. Pn cos h lambda n y plus Rn sin h lambda n y sin lambda n x. Okay, this one. Okay, so let us write that one. Okay, what we have to write? That implies Pn cos h lambda n y means cos h, y means 0, cos h 0 plus Rn we have taken Rn sin h lambda n y, sin h 0, sin h 0 into sin lambda n x is equal to t1. Okay, so this one, one thing actually we missed here. Okay, so already we have taken n is equal to 1, 2, 3. So in the generalized solution, when we are writing xn is equal to bn sin lambda and x, we will add a summation here, n is equal to 1 to infinite. Here also n is equal to 1 to infinite. So here also we will add n is equal to 1 to infinite, n is equal to 1 to infinite. Here also n is equal to 1 to infinite. Okay, clear about that. And here also we will add n is equal to 1 to infinite. Okay, clear about that. So in this equation also we will get summation of n is equal to 1 to infinite. Okay, that implies what we will get here. Just look at this one. We know that cos h0 is 1 and sin h0 is equal to 0. So we will get summation of n is equal to 1 to infinite Pn sin lambda n x is equal to t1. Now this is that means one such equation which can be solved by using Fourier's half range series. Okay, so Fourier's half range series. So here this is fx, and this is bn, and this is sine of lambda n x. So Fourier's that means half range series will give us the solution, and this is applicable to x between 0 to L. Okay, so the Fourier solution for this would be, okay, so applying Fourier's half range series, we can write what we can write. Bn is equal to, means in this case Pn is equal to 2 by L integration of, then integration of what? Limit 0 to L, and what is there? This t1 will come this side, t1, then sin lambda n x dx. Okay, 0 to L sine lambda n x dx. Now what the value we will get here? See, so 2 by L as it is, 2 by L. Okay, now T1 also we can take out because T1 uh, is not a function of x. Okay, so we should take it out, T1. Okay, clear about that. So T1 is out. Now sine lambda n x, integration of sine lambda n x, 0 to L sine lambda n x dx. Okay, what you will get here? Hmm. This is equal to 2t1 by L sine lambda n x integration. We will get minus cos lambda n x by lambda n x. So how can you do that? Take lambda n x is equal to anything like u, v, or anything else. Okay, and in this way you can obtain the value. So if we'll take this one 0 to L, we'll directly write okay here. Okay. So what it is, sin lambda n x, you will get minus cos lambda n x by lambda n in, and limit is 0 to L. Clear? Now lambda n should be taken out. Lambda n should be taken out. And what you will get? 2t1 by L lambda n. L lambda n minus cos lambda n x 0 to L minus cos lambda n x 0 to L. So look at this, and if you will use the upper limit here, lambda n L. Lambda n L means what? Lambda n L means what? See, lambda n value you have obtained. Lambda n L means lambda n L means this one 2n minus 1 pi by 2. Now 2n minus pi by 2 means cosine of that will give us 0. Okay, 0. So upper limit will give us 0. Clear? Upper limit will give us a 0. Clear? Now this will give us 0. Now if we'll put 0 here, then minus of minus 1 because cos of 0 is 1. So ultimately we will get 1 for that. So what you will get? 2t1 by L lambda n. But lambda n is equal to what? We know lambda n is equal to 2n minus 1 by 2l pi. So write that one means 2t1 by L into 2n minus 1 pi by 2l. The 2l will be written at the top. L cancel. It will give us 4t1 by 2n minus 1 pi. Okay, clear about that? 41 by this much. So finally what we got? We got Pn is equal to 4t1 by 2n minus 1 pi. This is equation number 11, I think. Okay? Yes, 11. This is equation number 11. Then let us come here. Now Txb is equal to T0. Txb is equal to T0. So let us use that means this one. Okay, as it is. So what you will get here? When you use Txb means y is equal to b. Okay, what we are getting? We are getting like this. Summation of n is equal to 1 to infinite Pn, then cos h lambda n b. Here it will become lambda n b plus Rn sin h lambda n b. Okay, into sin of lambda n x is equal to T0. Now look at this one. This one already we have taken. Okay, here Gn. Gn. Only thing is that the value of y need to be replaced here. So Gn is equal to what? This one. So we can replace this one by Gn. That implies summation of n is equal to 1 to infinite gn, okay, sine lambda n x is equal to t0, where gn is equal to pn cos lambda n b plus rn sine lambda n b. Now this gives us again a same type of a condition like this. So let us use the Fourier half range series to find Gn. Okay, use Fourier's half range series to find Gn, as Gn is equal to same. Here the limit is what? Because here that means we know that x, here also x, so the limit is 0 to L. Okay, so let us take 2 by L, 0 to L. Here T0 sine lambda n x dx is equal to Gn. Now what the value will get? 2T0 by L, 0 to L, sine lambda n x dx, sine lambda n x dx. That is equal to 2T0 by L into cos minus cos lambda n x by lambda n, limit 0 to L. What we will get? That is equal to 2T0 by L into this one, minus cos lambda n x will give us 1 if within the limits 0 to L, and by lambda n. So we will get 1 by lambda n. This will give us same 2T0 by L into 2n minus 1 pi. At the top it would be 2L. L cancel. It will give us 4T0 by 2n minus 1 into pi. Okay, what it is? Gn is equal to. So we got Gn is equal to this much. So we have Pn and Gn. Now what? Look at this equation. Okay, in this equation, we have taken Gn is equal to Pn lambda n b, cos h lambda n b, and Rn sin h lambda n b. Okay, let us use that one here. Okay, that implies what? That implies Gn is equal to what? Gn is equal to Pn cos h lambda n b plus Rn sin h lambda n b. This one. That implies Rn is equal to what? Rn is equal to Gn minus Pn cos h lambda n b by sin h lambda n b. Now substitute the values here. If we substitute the values, what you will get here? Gn is equal to 4T0 by 2n minus 1 into pi minus Pn is equal to 4T1 by 2n minus 1 into pi cos h lambda n b by sin h lambda n b. This will give us 4 by 2n minus 1 into pi whole into T0 minus T1 cos h lambda n b by sin h lambda n b. Okay. Now we got the value of Rn here. This is equation number 12. Equation number 12. Now we have obtained the values of Rn here and Pn here. Now the general solution is, okay. Now the final general solution is general solution is. So what is the final general solution? What is that? That is T n x comma y is equal to summation of n is equal to 1 to infinite Pn cos h lambda n y plus Rn sin h lambda n y whole into sin lambda n x. That is equal to summation of n is equal to that implies T n x comma y. Let us put the values here. 1 is equal to n is equal to 1 to infinite. Now Pn is equal to what? We got 4t1 by 2n minus 1 into pi cos h lambda n y plus Rn means what you got? 4 by 2n minus 1 into pi, okay, pi whole into t0 minus t1 cos h lambda n b by sin h lambda n b whole into sin h lambda n y, okay, into sin lambda n x, okay, or we can write in simplified form Tn x comma y is equal to, take 4 by 5 out, 4 by pi out, we will write 4 by pi summation of n is equal to 1 to infinite, okay, bracket starts t1 by 2n minus 1 cos h lambda n y plus 1 by 2n minus 1 into t0 minus t1 cos h lambda n b by sin h lambda n b whole into sin h lambda n y bracket closed into sin lambda n x. So this is the required solution. Okay, this is the required solution. Clear? I hope you understood this one. Please like, share and subscribe our channel. Okay, uh, actually this question contains two questions. Okay, one question we have solved, one more question remained. The second question will come shortly. Okay, second question where the boundary conditions are changed. Okay, so like, share and subscribe our channel. Turn the bell icon on so that you will get notification whenever the second answer will be posted. Thank you.